like the biggest parts of it. Okay. So first thing, non-intersecting lines means just that they don't intersect. They don't touch each other. There are two of these. Usually people are familiar with one kind of line, like a word for two lines that don't cross. There's one very common one. Does anyone know a term for that? Lines that don't touch each other? That one's parallel. Okay, so parallel would be the common one. Okay? And that would be the one that you guys deal with mostly, because that's the classification for lines that are like in a two-dimensional flat plane that don't intersect. And 90% of the book is in a two-dimensional flat plane. So the other one you're not going to see as much. You do need to make sure you get the definition down like exactly as it says up there. Coplanar is a very key word for this. Coplanar is what's going to make it on the same plane, therefore making it on a flat surface. Okay? So they never intersect and they're coplanar. The other word, which is skew, again, these are lines that don't intersect, but now you're into like a three-dimensional kind of situation where you've got them passing over top of each other. The way you guys would essentially test this is basically, if you see two lines that look like they're going the same direction and they don't cross, they're parallel. If they look like they're going different directions and it's somehow conveyed to you that they don't cross, they're skew. Okay? So skew lines would be like one going this way, one going beneath it, like that. Okay, so one's kind of hovering above the other one. It has to be three-dimensional for that to work. So the difference is the first one's in like a two-dimensional kind of situation, the other one's 3D. For you guys testing this today, just in terms of a definition, I'll probably give you a kind of drawing like that, where it's almost like a box. And they would say maybe list a line that's parallel or line that's skew. This little symbol right there, the double lines, that's just how you note parallel. So anytime you see this right here, that's telling you that these two lines are parallel. It's telling you these two lines are parallel. Okay, this notation will come up all the time. The other thing is, if you look at the diagram, the little arrow, like kind of in the middle of the things, the lines, that's also how on the pictures they will note parallel. So if I gave you the drawing, or even if I just drew two lines, okay, and I wanted to convey to you that these two lines were parallel to each other without actually having to write anything else. Again, this is only talking strictly in terms of a diagram. The way I would do it is I would just put a little arrow. So if you ever see something like this, that's telling you that they're parallel. Okay, which, like this little stuff, is very important for things down the road, because there's going to be specific properties that come from parallel lines. And if I was going to write this again using that notation, that would be line AB is parallel to CD. Okay? All right. Now, skew doesn't have like a little symbol or something. We don't use it that often because it's, again, three-dimensional, as opposed to the majority of the stuff you do is flat. In the picture over here, if I, like a type of problem I would do is I would say, look at line AD. And I would say, all right, here's line AD up here. And I would just ask you to name me a line that is skew to AD. And again, the way you would do that, if that was all the problem asked you to do, just find a line that looks like it's going in a different direction as AD that does not come in contact with it. Like,
EC?
Like which one?
EC? B.
Oh.
Let's just say a little. EF.
Well, no, here, it can't come in contact with it. EA would connect with it right here, so it can't be that. It can't be this one because those are going kind of in the same direction, yes?
BF.
So BF would be one.
CG.
EH, no, EH is going again same direction.
CG.
So HG would, EF, all those. The other ones that wouldn't be would be Those two right there, because those come in contact, and then all the ones that are going the same direction. There should be 4 that are, right? CG, BF.
So they can't go in the
Yeah.
same direction and they can't be parallel?
If they're going in the same direction, they're parallel.
Oh.
Okay? Now look, me saying that, that's just something you use in your mind to check. It's not a definition for it. Okay? So I will ask you to define these at some point. So please, on like a definition, if I say define parallel lines, don't write the lines that don't intersect that go the same direction. I won't give you that. Okay? Word transversal is going to be another definition. I'm not going to ask you to define this, so if you don't technically have it fully written down, it's not a big deal. When you see the word transversal, all that is, it's a line, okay? And that's it. There's nothing else that's for that. Now, what you guys are going to have to use this for is when you actually draw a transversal, which a transversal would look like this line right here, the T, the one they have is T, okay? So when this line is drawn so that it's intersecting these other ones, therefore that's what makes this a transversal, it's intersecting 2 lines. What happens is you create 8 different angles. There's going to be 4 terms that you guys use to pair up these angles. We've already used some, okay? I'm not including those in the 4. There's 4 new ones. And what's going to happen is, like, for right now, we're just going to go through the names, and then we'll apply it to, like, parallel lines. But in general, all you need to know right now is transversal is a line. So it's nothing more than a line. It's a line that fits a specific situation, meaning it's going to intersect multiple lines at the same time. It's not limited to 2. It can be 3, 4, however many. But for the most part, you guys work with it as 2. Okay. The way this thing is labeled, like exterior, interior, exterior, is also going to be important for the naming part. So if you want to write those in there as well, like you should really draw the picture out if you haven't, and label these as interior and exterior. When they put exterior, exterior just means it's on the outside of like these 2 lines. Meaning like these 2 lines, the way they're drawn, there is a region between the 2 lines. This whole region that they have shaded between the 2 lines is the interior. So interior just means it's between it. Exterior just means it's not like in between the lines. That's all. Exterior in general just means outside, and interior means inside. Okay? All right. Now, the angle pairs with the pairs of angles that you deal with in terms of a transversal kind of situation. And again, these are only going to be words that come up if you have a line that fits the definition of transversal. If this line was gone, we'd simply be looking at those 4 angles, which is like last chapter. In all the words we've already had, they don't magically go away because we're dealing with something else. Like these 2 angles right there, 1 and 2, I mean, that is still a linear pair. 6 and 8, those are still vertical angles. Okay, we're just adding stuff on top of that. You still need to use all the properties we already did. Everything that we do just kind of builds on that. So everything we've covered in the past is still going to be utilized, and it's still going to apply to what we're doing. Now, with these, there are going to be 4 classifications here. Okay? The way that these are going to work, like I'll write the names out and I'll tell you which pairs fit. The angle pairs of transversals deal with you taking one angle at this intersection point and matching it up with one angle down at the other intersection point. And again, these intersection points are the ones that are formed by that transversal crossing the line. Okay? So you pick one at this one, match it up with one down here. You don't match up ones at the same intersection point. Those are things we've already done, like linear pair and vertical angles. All right, first one is alternate interior angles. Okay? The name of it kind of tells you where to pick them at. So this word right here, interior, means I'm only looking at the 4 angles that are on the interior part. Such as like these two are on the exterior. So at this moment with me classifying these, I don't care about them. These two right here are on the exterior, so I don't care about them. So 3, 4, 5, and 6 are my interior angles. And again, what I'm doing is I'm picking one angle up here, like either 3 or 4, and I'm going to match it up with one down here. Okay? Should I start with angle 3 or 4? 3. 3 was the first one I heard. All right, so angle 3 and, all right, alternate. Alternate means you're on opposite sides of the transversal. Such as, here's my transversal. Angle 3 is on the right of it, correct? Yes?
Yeah.
Okay, that's the right. So that means that when I match up the one down here between 5 or 6, I want the one that's on the left side. Because left and right would be on opposite sides of the transversal. So angle 3 and angle 5 would be an example of alternate interior angles. Okay? And then 4 and 6 would also be, because 4 is on the left, 6 is on the right. They're alternating sides, and they're both on the interior. So that'd be it. Okay? No properties with these right now. I'm not doing any like problems involving numbers right now. This is nothing more than identification kind of. Okay? All right, so that's the first one. All right, second one we'll do is alternate exterior angles. Okay, so same idea I just used, but now when I pick them, right, it's got the word exterior in it. So that means I no longer am using these to match anything up. 1 and 2 are exterior angles, so are 7 and 8. So again, I'm picking one angle up here, matching it with one angle down here. So if I started with, should I start with 1 or 2? 2, fine. So I start with angle 2. If I look at angle 2, that's on the exterior. It's on the right-hand side of that transversal. So when I come down here and match it up, since it's using the word alternate, I want to match it up with the one that's on the left. So 2 and 8 would be alternate exterior angles. And then so would, what's the other one? 1 and, what's the other number? 7. Okay? So interior and exterior is telling you where to look. And again, interior is between the two lines that the transversal is crossing. Exterior is outside of that region. And then alternate just means flipping sides. All right, next one we'll do same side interior angles. Okay, so again, the word interior is in there, so that means I only care about those 4 angles that are on the interior. So 3, 4, 5, and 6. And then the difference between this one and this one is when they say same side, that just means you want to pair up the ones that are on the same side. So 4 and 5 are both on the interior. They're both on the left-hand side of that transversal, so that would be an example of one. So with 3 and 6. Okay? All right, the last one is called corresponding angles. Okay, this word right here, corresponding, from now to the end of the book, will always mean in the same position. It's like basically if you take 2 things, stack them on top of each other, the things that overlap are called corresponding parts. So in the case of what we're working with here, again, the whole process of dealing with a transversal, going through lines, is you're picking one angle at this intersection, matching it up down here. So when I say you're stacking them, it's like in your mind you have to visually say, I'm taking this set of angles and I'm stacking them right on top of this one. so that the parts that overlap would now become corresponding. They'd be sitting in the same spot. So like if I just cut this portion out and slid it down, I didn't turn it, I didn't flip it, nothing else, just slid it down. That means that like this number 1 would slide down to here, correct? You agree?
Yeah.
Yeah. 2, if I just slid it down, would go there. 3 would move to there, and 4 would be there. Those are your pairs, okay? Because then once I slid them on top of each other, the ones that overlap would be corresponding. That's essentially what corresponding means. It means they're overlapping. They're on top of each other. They're in the same position. All right, so 1 and 5. Is it 2 and 6? 4 and 8 and 3 and 7. Okay. Again, all we're doing right now is identification. Like you're going to have a picture, and it's going to say, name me a pair of alternate interior angles. Or name me some corresponding angles. So on. Nothing more than that. Obviously, I would hope if every problem was set up the exact same way, it would be very straightforward. You can just match up this. Not everything's going to be set up this way. I can give you ones that are. Give me some room. Okay. I could give you a drawing where I've got 2 lines going that way, then I have a line going this way, where this would now become my transversal. In terms of this, sometimes this throws people just because the original is given to you there. So you just got to imagine all the pairs we just did are still going to apply, but now this picture's kind of turned sideways. So like this section here going up and down is now the interior, and this is the exterior, and so is that. Okay?
Do you have a double interior?
No.
No. What if you had another line, like 2 angles intersecting like that?
What do you mean?
Could you have like 2
Like-
triangles?
Like that?
No, not really. Like the line that you have up there, the horizontal line. What if you had like another like one going like
That?
that? Yeah.
There's multiple ones. The way you isolate them is, and I'll use this for example, when you guys are pairing things up, you want to kind of isolate 2 intersection points. If there's more than 2 intersection points, eliminate the rest. Obviously, if it's in the book, you can't like make them erase or anything.
Yeah.
You just have to kind of cover them up. Meaning, like, do I have any questions with this one? No. Let's say with this problem here, if I said something like angle 1 and angle 10, if I looked at those two, I said, all right, look at the picture. I want you to determine what kind of angles, in terms of the things we've just done there, which one of those 4 names would fit 1 and 10. Okay? And the way you got to kind of deal with this, if the extra intersections kind of screw you up, just eliminate the intersection that does not involve either one of those. 1 and 10 are here and here. That means this thing over here, I don't care about it right this second. So you just gotta kind of imagine this whole portion is just gone. So that if I redrew it without that there, you would have something like this, where like 1 is here and 10 is here. And again, here's my 2 lines. This is the interior, this is the exterior. Okay, so their interior angles, are they on the same side or opposite sides? Same side or opposite, that's all you need to do. Opposite?
Opposite.
So that these things here, 1 and 10, in this picture, even with this thing being there, you just pretend it's not. These are alternate interior angles. So if you have more than 1 intersection point, just throw it out.
Is 2 an interior angle?
Depends on what else it's paired with. If I did like angle 2 and angle 8, If I did 2 and 8, same question. Like I said, here's my picture. Look at angle 2 here, angle 8 here. I'm looking at these two intersections. So again, I don't care about anything over here. This has nothing to do with my problem in terms of this. If I redrew this picture with like this portion gone, it would be kind of like 2's here, 8's there. Again, this is the other intersection, but it's not being involved with those two angles, so I don't care about it. So these are my two lines. So all the space between them is the interior. That's exterior. So is that. Are they on opposite sides? So those two would be alternate exterior angles. Okay? You have to go through it. If there's just two intersection points, it's straightforward, man. You just go through and match up with the stuff I had there. When there's multiple, you have to sit there and determine in your head, these are the 2 points I care about. This stuff doesn't matter to me. And then just start matching them up. Label things interior, label them exterior. So you would agree these are alternate interior angles, yes? Okay? Not the one that's up there. That's a different thing. These two alternate interior angles. So we've agreed that's the same number and they're alternate interior angles. So do you think if I tested the other pair of alternate interior angles, the same kind of situation would happen where they're both the exact same measure?
Yes, sir.
You better believe that, because that is something that's always going to happen. You need to make a note somewhere on your paper. Alternate interior angles will always be congruent. Always going to be the same measure. All right? Again, this is what you need to do if you're going to make a list with all these. You have to say, I've got a transversal passing through two lines that are parallel. If the lines are not parallel, this doesn't happen. All right? So alternate interior angles are always going to be the same measure. They're always going to be congruent. Okay? All right? If I took this out, again, we already said that number's the same, yes? This angle here and this one right here. Out of the four, which one? Well, really out of the three. We've already done alternate interior angles. So this angle and this one here are those alternate exterior, same side interior, or corresponding angles. They're both the same number. They're both corresponding angles. Therefore, I could go through and do it with every single pair that's up there, and they're going to give you the same result. Corresponding angles, guys, are always going to be the same measure. So alternate interior angles and corresponding angles will always be congruent to each other. Again, make a note of that. That's going to be a huge thing. Those two are going to be the ones that you use the most from now to the end of the book. All right, those are going to be the biggest ones. Okay, so corresponding angles and alternate interior angles being the exact same measure are going to be fairly important thing. Okay. Let's get rid of you. All right. If I do, which one's next? Alternate exterior. All right. Alternate exterior. Again, are they the same measure? Do you think that would always happen? You should, because that's true. So you got three things here. If you've got two lines that are parallel, like this line here and this line here, if they're parallel, and the transversals going through them, alternate interior angles are congruent, corresponding angles are congruent, and so are alternate exterior angles. Okay? So those three are congruent. That's good things, because if you can set things equal to each other, it makes problems much easier. Right? The only one we haven't done yet is the same side interiors. Look at that. Yeah. Alright, so let's alter this there and do that one. Okay, so that same side interior angles. Yes? Is that number the same number? So these are not congruent. Okay? Yeah, you better not say that. Big trouble. But can someone add those two together for me? 72. You think it's 180? Make sure it is. It's 180? All right, so same side interior angles. We'll always add up to 180. They're supplementary, no matter what. Again, as long as these two lines are parallel. If this line and this line are not parallel, none of this stuff happens. Like, you can't do anything with it besides classifying, okay? So the first part of like the work you'll do is going to be identifying them. Second part is going to be using those four things. Really, three of them are congruent. The last one adds 180 to solve equations. This is the part where you actually have numbers involved. So if I gave you problems like down to start, I'll do that one next. This one. So you see the answers. Okay. This would be a very typical problem that's actually would be extremely basic kind of problem because there's no variables to solve for or anything. So, and again, the reason this would be easy is because these little marks, again, mean that they're parallel. So as soon as I see two lines that are parallel and then something else is passing through it, that means that those pairs I already said that are congruent are equal, like alternate interior, alternate exterior corresponding, and then the other ones have to be supplementary to it. You can still use all the old properties as well. Meaning like if this is 55, what's this? 55, because what kind of angles are these? How would you classify these two, the ones that are right across from each other at a point? What are they? Starts with a V. What is it? Vertical? That's what you should be saying. You should be saying vertical. All right. That's going to be something that's used quite a bit too. That's why that word I'm going to keep thinking. All right. So like this problem, the two answers you're either going to have is 55 for all the ones that are the same. Like angle 1 is 55. What do you think angle 5 is? 55, because those two are alternate interior angles. So since these are alternate interior angles, they're congruent. If that's 55, what's this? 55. These two right here have to add up to 180. I could do it as a linear pair. These two are same side interior. They add up to 180. So finding the other number is just going to be you subtracting that from 180. So all the other ones are 125. 2, 4, 6, and 8. So it's not that hard of a problem. Where this could be a little bit involved would be if I said explain how you're getting each answer. Which would mean you put something like their vertical angles, or their same side interior, or their alternate interior angles, or corresponding, or something like that. Okay, it's not like a long, detailed explanation for it. All right. What if I limited this and said, okay, find me the measure of angle 2? Do you think you could do it? 75?
I bet it's 105.
You bet it's 105?
No, angle 2, you said?
Yeah, all right, here would be the trick with this. The only way this will work is if you've got like two sets of parallel lines, which I do. Like I got parallel here and here. Meaning I can take this number and kind of transfer it up over here using the properties we have. So like if I ignored this whole part, like if I just pretended this whole 1, 2, 8, 4, and 6 were gone. And I just looked at over here. Are these alternate interior angles? Yeah, so that's 105. Is that a vertical angle?
No.
Yeah, so that's 105. So I know both of these are 105. All right? And once I have numbers here, I can come back and say, well, let's pretend this is gone now. If I looked at these, are 5 and 8 alternate interior angles? So if that's 105, so is that's a linear pair right there. So if that's 105, that's 180 minus it, so that's 75. Okay? You can go all the way around and give me this. All right? Okay, I'm going to show you one other one. One like this. Just because look, it's a little different looking than the rest in the fact that just with the idea that I don't have something where all the transversals I've done, have been like this, where they're kind of sticking out. These are just kind of like clipped down versions, meaning that if I took this side and like extended it out,
It's just like that other one we did.
now I've got, like, if I look at this part over here, here's my transversal, like this is the transversal. These are the parallel lines. So again, if I forget this whole part over here is gone, like just pretend that section with the Y is gone. It doesn't even exist. If you imagine that being gone, you've got something where you've got 2x right here, and x minus 12 here. These are the same side interior, which with the same side interior, with the parallel lines, what was the property? They add up to how many degrees? What was it? 180? So if I can imagine that, and you'll probably have to draw things on here, like extend them out just so it matches with pictures you should have. For me to get x, I would just do those two add up to 180, right? 3x equals 192. What's 192 divided by 3? Quick, quick!
140.
What?
Wait, I got it. I got it.
How many times does 3 go into 19? 16, right? 4? There you go. And now we do the same thing over here, right? These are still, like if I extended that out, those two would be same side interior angles, that meaning that they add up to 180.
Wait.
Ah!
Oh,
They're not equal. If they don't look equal, here's the thing. This is like one of those times. This is like one of those moments where I will definitely tell you if you're doing the problems. If they look equal, they are. If they don't look equal, they aren't. Okay? Usually with this stuff, as long as you see the parallel lines, if you see one angle match up with a bigger one, they're going to add up to 180. That's for what we're doing right now. Okay? So like this is an obtuse angle, that's acute. They're obviously not going to be equal, so I have to add them up to 180. You don't have many other options right now for solving these problems. Okay, whoops, it's 160, so y is 40.